So we've seen problems that look like this before, actually. When we've seen this type of problem before, we've been able to solve for x by graphing. And so we'd break out the graphing grid and we'd graph both these. So let's just do this one together really quick here. So for the left side, what would the plus 6 do? Which way does that move it? Up, down, left, or right? It's in with x. Therefore, it moves it in the x direction. Specifically, plus goes left. So yeah, I'm going to go left 6. And then the plus 3 goes up. Yep. And so I'm going to go left 6, up 3, plot my first point, and then it's square root. So I know the graph of square root looks like this, so I can go ahead and plot all those points, and then draw the graph that goes through them. All right. Then, what about the 7? When we just have the 7 by itself over here, yes, it's going to be a line, but which way is that line going? Is it slanted, or is it horizontal?
Horizontal.
Yes, it is horizontal, because there's no x in it. And if there's no x in it, it's just a horizontal line. So this would be our graph. And so we do all that work to make the graph, just so we can then look at it and tell what the solution is. So in this case, we're asked to solve for x, so what does x equal?
Ooh, I know. 7.
Remember, we're looking for the x value, not the y, so it's not 7. It's that x coordinate there. So yes, it is 10. Now, the thing about this particular problem, though, is that it does seem like quite a bit of work to have to set up the graphing grid and make both graphs, right? And there are times when we still have to do that. However, I don't want to be doing that all the time. So today we're going to be looking at how we could get to the same result algebraically, so we don't have to make the graph. You still can, but you don't need to. So, take a look at this problem. What if you're asked to solve something like this? You'll notice square root of x plus 6 plus 3 equals 12. The 12 isn't on our graphing grid, is it? And our answer would be so far up here, it's probably going to be out like in the hundreds or something like that. I do not want to try to do that by graphing. So, algebra. Have this problem written down. This is very similar to the first one, but it is different. So make sure it's written down. And so, in order to do this algebraically, step 1 is to get the square root part of the equation by itself. Because remember, I'm undoing this. So I'm going backwards through the order of operations, backwards through PEMDAS. We're going up through that list, remember. And so the first thing I do is get rid of addition and subtraction. The last thing is parentheses and exponents, which is our square root here. So I save it for last. All right, so first thing I want to do then, subtract that 3 from both sides. And yes, be writing this down in your paper as we go. When I do that, I'm left with just the square root of x plus 6 on the left side. And that equals 9. Now, before I talk about what we will do next, I want to tell you about something we can't do here. Because sometimes people say, well, can't I just turn that into the square root of x plus the square root of 6? And the answer is going to be no, we can't. That's not allowed because of that plus that's inside of the square root. Anytime you have multiple terms inside of the square root, it makes it that much more complicated, and we cannot just take the square root of each part of it individually. I could get into a lot more detail on that, but we don't need to right now. Just understand that it's a rule, and maybe later on this year we can get into why that is the way it is. But for now, then that tells me that in order to proceed with this, I need to now be able to get rid of that square root. Because notice on the left-hand side, the only thing that's over here, the thing that's on the outside of everything, is that square root. So I got to get rid of it. That's why I got it by itself. What's the opposite of taking a square root?
Square.
And so it is squaring it. And so what we're going to do then is we are going to square both sides of this equation. All right? So then, in order to show that work then, I'm going to write that both sides now are to the power of 2. So I'm going to show that that is being squared. There we go. And that this is being squared. Right, now, Remember, I chose to square it because squaring it undoes a square root. And so if I square a square root, I just get rid of the square root. Whatever was inside of it is left behind, exactly as it was, untouched. So we are just left with the x plus 6 on the left-hand side. That was why we squared it, to get rid of that. Now it's much simpler on the left-hand side. On the right-hand side, though, I actually got to do that work. I got to do the 9 squared. What does 9 squared equal? So yeah, the 9 squared ends up giving us then 81. Now we dealt with the tough part. You know what to do from here, right? Get that 6 out of the left-hand side. So we subtract the 6 and we subtract the 6 from both sides. You end up with x equals 75. I'm glad I didn't have to do that by graphing. Because if we tried to do that by graphing, it would have to go out a long ways for us to be able to tell that they cross at 75. So this algebraic method now allows us to deal with something that we wouldn't have been able to deal with otherwise. So then, having done that work, I got a couple pieces of notes for you to take. So these are formal notes, some definitions. The first set is more of a need-to-know basis kind of thing. Because that first part here is I do often see people mixing up what it means to square something and what it means to square root something. Take a moment, look over this, write down any pieces that you want to have on your paper as a reminder, including the fact that the inverse operations, or that square and square root, are inverse operations. That is, they undo each other when we're solving an equation. So make note of that part and any of the rest that you want to. And whereas the last set of notes was kind of write down what you need, I want you to write down all of this. There's not actually that much. I just printed it nice and big. But please write down all of these notes because it reminds you of the process. How do we solve for square root equations? Reminding us that we have to start by getting the square root by itself. And then we square both sides and then solve from there. And also a little bit of hint down here about how we know when to use what. And I'll talk more about that here in a minute, but I'll give you a chance first to write these down. So for those last 2 bullet points now, you'll notice that it's telling us when to use each method now, because we now know 2 methods for solving a square root equation. And so anytime now that you see a square root that's just set equal to a number, go ahead and use the algebra. So basically what we're learning new today, use that method. Do this if you just have square root and then it equals a number. Use the graph when the square root is set equal to anything else. So like for instance, if I had the square root of x equals to the absolute value, even with all the numbers in there and all that kind of stuff, I would want to solve that by graphing. If I had square root of x equals to something involving x squared, I'd want to do that one by graphing it. Because there's some layers of complexity that come up in some of these other scenarios, which we just aren't dealing with yet today. All right, so now having seen these, let's do one more practice problem here together to make sure we have the ideas down. So please write down this problem and then solve it on your own first, and then we'll go through it together to make sure that you're doing well with it. So you get 27 out of it. If you're running into any problems, go back, compare your work to what's shown up here, because there really is just one way of doing this one. This isn't the type of equation where you might have started by doing something different. Yours should look exactly like what you see up here. And so if there's any difference between what you see up in this work and what you have on your paper, make that correction so you're going to be able to do it correctly in the future.